Okay. Hi, I'm Tim Wilson. If you don't know me, I'm a senior at Grandview, and this is my senior projects presentation. And my company's my logo is this, made by Vincent Dick. I'm another senior here at Grandview, the March. A little introduction to me. I've been in tech draw, advanced engineering design, and engineering design, which is 3 years of just basically Solidworks and a little bit of architecture in tech draw. I have my CSWP, which is a certification for professionals in SolidWorks, and I have one CSWPA for sheet metal. And over the last summer, I worked as a sprinkler repairman, and I was working in 90-degree weather, digging with a spade that's like that long, that thick, digging down 6 inches, and having to like work it back and forth to get the grass loose, because you don't want, when you're leaving, and you lift the grass up with your hands, you have to go back and loosen it all up. And one time I was working in that big hailstorm this summer. It was just some of the hail stones that came down. And this summer I hated it. I was dying every time I came home from work, just basically going to sleep. And but I knew I was going to this class the year before, so this was my idea over the summer, and because I just hated it. And as I was going through, my boss, who was always helping me learn and get through the digging and trenching, he always enforced the idea that for the customer, you need to have it look like you were never there, as putting in the sprinklers and repairing everything, so they don't have to worry about it and just pay you leak. And so it's all done correctly and everything. And so that was one of the main ideas in my project, was to keep that grass there the whole time, and that's what this little plow at the front is. The project objectives for this used to be SolidWorks CSWE used to be my goal, one of the goals for this project, but the CSWE was going to take too much time, and during the year I took a job shadow with Micron, which is a manufacturing company who works in automation, and they use a program called Autodesk Inventor. So I learned that other companies use different programs than just SolidWorks, so I didn't want to waste any more time or money investing in SolidWorks if I might not be using that in my professional career. And I wanted to be a better public speaker, and I also wanted to learn about just the basic knowledge of how to make something or go through the process of having an idea and manufacturing, and all the different steps of the prototypes and ideas and mock-up sketches. I started in October. We all did project proposals, and I didn't really know what I was doing. It was all generic, and so this all basically changed. Well, in the beginning I stuck to it, just researching through it, and how tree roots change the dirt physics, and just if I would need to know any of that. But as I was going through it, it was more for like more precise things that you would have to know the type of dirt we're in and all the different types of ways you would need to dig in that situation. But because this is just using brute force, using a chain to cut through it, you don't need to know the exact type of dirt or how you need to change the digging work. I was also researching gears and motors and stuff, and I found a video on spiral gears, and but it didn't really apply to mine. It was mostly for cars and everything, and it made it way hard to use. But if I was going to go with spiral gears, I didn't even need to for this, but it creates like angular torque along the axis, and that requires a lot of more steps to keep the transmission box together. It's a lot more bigger and bulkier, as opposed to just straight cut gears. I was also researching how different types of trenches like fail, and there's a bunch of different types like sliding and topping and boiling. Boiling was one I was worried about in the beginning when I first heard about it, but it's relating to the water table where all the water is, you dig so low that the water starts seeping into the bottom and like making mud, and could eventually even crumple the wall if it does heating and squeezing instead of boiling. And but I didn't have to worry about this because water tables are all way too low for sprinklers, and I would be able to dig that low with my trencher. In the beginning, I didn't really know what my idea would be, so I just had a box, and I knew I wanted to plow at the front to keep the grass good after I dig through it, and put handlebars on there, and these is where the wheels would be. Didn't know where any of that would be or how it would look. So my next revision was just a bigger box, and I looked up just on Ditch Witch. It's another company who makes trenchers, and they're probably one of the biggest trencher makers. I looked up their smallest model of their C12, I believe, and this is the engine they used for it. So I just looked up the specs of that, how big it was, and then I put a cut in it for where the engine would be. And the reason I picked this engine for this design was for just the reasonable prices, but this is not the same as the one that's on there. This is a smaller version. My advisors were Rodney Preddy, my grandpa who lives out in Delta. He was there to help me learn about welding, all the different types of manufacturing processes to get to a final product, and teach me how to do it safely and make it strong and actually be able to work. And then my support advisors were Chris Vitrizzi. He's a first cousin, and he is in some sort of construction, and he manages like tools and rents them out to other people. And I thought he would be a great fit for making a tool, but he wasn't able to help me a lot with trenchers because he didn't deal with that too much. Another support advisor is James Serco. He's here in the audience today. He was supposed to be helping me with the Solidworks design, but I kind of moved away from that in my project, so I didn't get to use him too much. But in the beginning, when I was doing the mock-up sketches, I sent them to him, and he gave feedback about how it needs to be heavy enough to keep all of them forced down and dig a good trench ground instead of like bumping up and not having a controlled depth. My other two advisors are my mom, Stephanie Wilson, who's a financial support and a sounding board for ideas, and then Olivia Young, who's a spell checker and a moral support throughout the year, helping me also with ideas of my sounding board as well. And for advisor contact, I sat down with my grandfather over Thanksgiving break, and we came up with a big list of things I needed to research of prerequisites to know what I need, what I want for my trencher. And we slowly went through, and we finally found the groundhog. And then we also wrote on these boxes. This was me sending him my sketches, and he had to go over them, and this is what he wrote on. And we talked about it when I was there over Thanksgiving. One of the big roadblocks and pitfalls was he lived all the way in Delta, which is a 5-hour drive without traffic. And one time we even went, and there was a car accident right outside of Georgetown, and we got stuck behind. And they closed off the road because the crash was blocking it with all the debris and everything. So we stuck there for another 2 hours, and it made the trip a whole 12 hours with going up to Boulder and getting this to me. Then up in Delta, this is my grandfather's shop that I used to finally come up with my product. This is how big it is. It's up to like, I would say 20 feet. You can see tiller there that we were going to use for the basic design, but then when I gave the idea to Jim Sorgo, and he said it needed more weight, so we really quickly threw away using that as a base to work off of, because I can't make all the engine and everything, all the other specials stuff. I just wanted to finally get a product that was with the ramp out the front, the plow at the front, and worked with all the other complicated devices that other people made, because engines would be a whole other project on its own. This is the original bar. We had to cut it up and shorten it for this because where the axle is on the wheel, the chain would hit it and ruin the chain. You'd have to go through the entire remaking the axle and putting it a little further back. So we thought had it for the solution of him being so far away, we had to lay out a plan really solidly, have all the parts picked out and what we wanted to do, and we eventually did that over spring break, but it took a while for us to finally have a good laid out plan. In November, I was researching more about, just to catch up to where I was in my all the other progress I did with my Solidworks. I had to catch up all the information with all the designs. And in November, actually, I had to research motor specs and modeling of the, I was, instead of researching grass and all that, because I quickly found out that it wasn't a good idea to, because of all the, that's the word I used earlier. It wasn't, like, the specifications weren't, like, precise enough for my project. And in the end, at the end of November, that's when we had the talk at Thanksgiving. In December, I worked on my design in SolidWorks for the third mock sketch, and I made a smaller plow at the front to make it so it was not taking too much power to push through the entire ground and crash to the side. So that's why you can see how it's much smaller here, just enough to take the space, the grass out of the way for the chain. So it's mostly the same. In January, I mostly threw out everything besides the journal. I was separating mid-year presentations from, and so I was doing mid-year presentations for the first part of January, and in the end of this January, we were looking for the base for what I could build off of, like the Grandview trencher we decided on. There's a bigger picture of the small trencher he had, and then there's a ditch-wish trencher, and it's just to show how mine is not supposed to be competitive with it. It's supposed to be a small homeowner or business owner type trencher to just do sprinklers, not putting big electrical lines or internet cables or anything like that. And I had to make a new plan because we couldn't meet over a long, like a 3-day weekend during February, and so that's when we had to make the plans for spring break and push it back to then, and started looking for all the parts to bring. In February, I had to do a bunch of height selection because I knew I was going to have to do that later, but in the end I didn't have to do it because it came on the groundhog trencher, and what I was designing was a lawnmower type height selector where you pull out from the spokes and put it onto another one, and it lowers it as you rotate it around the outside of the height selector. And then I started modeling the little edger you saw earlier, but then we just decided it wasn't good enough, and I stopped working on it after February. In March, I modeled more of the framework right at the beginning because make the full decision yet. And then right before spring break, I started getting ready for Delta V I made a bunch of SolidWorks plans on how, like, modeling it from just the specs he gave me off email. And then in the end, during spring break, I was working with my divider. And then into the 29th, I was working on a journal and updating on the website from all the work I did over spring break. During the spring break, we drove up and down to near Boulder, where we found a groundhog trencher for $1,100. And it was used, and all the parts we were going to buy for it were $1,500, and that wasn't even all the parts used in the groundhog trencher, so we just bought a whole one for about $400 cheaper. And then when I finally got there, we waited until the next day, and then in the morning we got up early, 8 a.m. early-ish. Then we started disassembling everything off of it that was like needed to be taken off, like the trunnion in the front here where all the bars and all these gears, motors and stuff, just to be able to get down to the base and take that off and be able to put it on our own base that we make. And this was, we got there on Sunday, right? And going through, it was on the weekend, so we couldn't even buy any of the stuff to make the base. So we were just going through and cleaning all the parts with gasoline as a solvent, old expired gasoline. You can see here the trunnion, which is in the front right there, which is the hinge. And it works with this height mechanism here, where a bar runs under it and attaches to that this hole right here. And when you move that this way, it pushes the bar under it that way and rotates it up because it's pushing this entirely this way. And this is the housing for where the trunnion was, because I didn't know how our base was going to, how our base was going to look at that. This was me designing a shorter bar. I used global variables in SolidWorks, which is a tool where you have a spreadsheet and you can set any dimension to a variable like X, and then in the and you can name the variables so it's organized, and then in the table you can just change the number whenever, and it changes it in the real sketch as well. And then as I was going through building this, I was designing it backwards, like flipped. So because the bar was originally out in front, and I needed the plow to put the grass out of the way. So I had to put the bar under and flip the entire base and the engine, because the engine didn't have any way to reverse which way the torque was coming out of it. So the bar would be the chain would be turning the wrong way, and everything would break across. In manufacturing this is us welding the bar together. He just had a big pile of metal in the back, and we found this U-beam and just put two plates on it, cut out like this here to the end, and so both sides were cut open, and we took two plates like this one here you can see, and we welded them on top. This was my first time doing a weld, and this is my grandparents, my grandpa's, and this is me, and that's really exciting. You can see how it comes through a bit on the right, because I held it too long right here. You need a really steady hand the entire way. You need when you're going through, you look for where all the metal is hot and glowing, and you try and follow right ahead of that, and fill in the hole so it's like even hole. This is us cutting out. This is the sheet of metal we used to make all the glue. You can see there, and it was a half sheet of standard steel. We had to use a grinder to clear all the rust off, so cut well and weld. Real good, strong resin. And then this is us using soapstone to sketch out the entire outline of it. And soapstone is a sort of chalky substance. It's it doesn't burn off like Sharpie would at 6,000 degrees Celsius. So while you're tracing along with your torch, you can follow along, not lose your place and have to freehand it the way through the weld. We use this as a ruler, straight edge, and we clamped it down on either side and followed it with the acetylene torch to cut it down. And acetylene, for the acetylene torch, it has two gases. It has acetylene and argon, I believe. And when you're using it, you have to turn on, acetylene and oxygen. And when you're using it, you have to turn on the oxygen knob on the bottom. I do not have a picture of it. There's a knob on the bottom. You turn it until the flame, just a little bit so the oxygen is coming out, and then you take a starter to the tip of it and start it. And it's a big, really broad flame, not good for cutting. It's a lot of black smoke is coming out of it. And what you have to do to hone it down is turn the oxygen until there's no more black. And then at the top, you turn it until the flame gets really short and thin. And then there's like little tiny, really like 1 millimeter flames, blue flames coming out of like 6 little holes on the outside of not on the outside, 6 little holes on the tip. And they're on the outside of a little oxygen type line. And those 6 are the acetylene, and while you're turning the knob on top, it hones down the flame. And when there's a lever on it to put more oxygen through and cut hotter and be able to actually make the cut. And when you push it down, you want the little millimeter flame to stay the same, just size the whole time. When you push it, aren't pushing it, and that's how you know it's going to be a cut. And for the welder, for welding, we set the big top plate upside down on the plate on the table, and had 2 magnet 90-degree holders, and you just set up the 2 side plates, one at a time, of course, to set them up and have you set up the 90-degree angles on the outside of the weld, and then you angle the metal slightly away from where you're welding, because all the heat and cooling is going to bend the metal towards the weld, and that's how you mitigate bend. And you can see that here, how all the welds are on the inside. I don't have a picture of the magnet corners, but you would put them right here, and it just sits like a 90-degree thing. In the crevices there, you can kind of see the welds. Every 3 inches, we did a 1-inch weld, and that's how he said to make a good, strong weld across the long side there. And to get the right settings for the welding, they have a inside panel where it has a graph, and you find how thick your metal is and what metal you're using. And for this, we had just standard steel 1/4 inch, and it was we had to get to 60 amps and 20 inches per second. And inches per second is measuring the amount of wire coming out of the center of the MIG welder. The wire is an 1/8 inch, and that's all the metal that's being added to one of the 2 other metals together. And while you're welding it together, sorry. Oops. And what I had, for welding, so it was MIG welding, which is metal inert gas, and the metal is referring to the wire on the inside of the welder and what's going through. And the inert gas flows over the entire weld as you're welding, and prevents oxidization and bubbles from forming in it with oxygen. just to make it a strong weld that holds together under a lot of pressure. And then we spray painted everything blue, and then that's all the piled parts before we started assembly. And then you can see us put on the bar there and the wheels and everything. You can see the bar. That was our first time seeing the bar not touch the axle, so we knew our designs had worked, making the bar shorter. And here you can see the handlebars, the adjuster back on there. And here you can see the right side of the centrifugal clutch. This is just a squirt heater, and there should be on here, you can see this gear at the bottom here. That is tension gear to keep the chain tension the entire time, not loose and flapping around while you're spinning through the turning. So, going through this, you can see the centrifugal clutch up here, and what it does is on the inside, it spins, and these two big chunks of metal here, they spin with the inside, and as it's going faster and faster, these springs start letting go, and then it engages with the outside and finally turns the entire length of like chain belts in the entire gear. Gear train. In April, I came to this and worked out with the DC machine earlier, or what I could, because I didn't have a grinder to reshape off the bottom of this front here, which kind of it catches all the dirt in the front and it's hard to push forward, and this axle being farther back has a lot of weight in the front, so it's hard to like lift up and move forward. 130-pound person could like push on this and just have their feet lift off. So that's not very good for using for a bunch of people and selling for a bunch of people. So I have to fix that or add some sort of power device to the wheel to move forward. And I'll start it real quick.
Not what he was there.
You're running on that side. The chain will pull the dirt all the way around, and then this eventually moves it all. The spiral on the end eventually moves it all away from the trench, so you can push the dirt back in with just your hands, and then going through the thing, you just see how everything works. Any questions?
Real quick. So, I saw your video.
Yeah.
You just kind of stood there. So, what would be things you'd do to like further this along so you could actually really use it?
Like I said, added power design to the wheels. Maybe make a new entire trencher with the axle more forward, or have some sort of weight mitigation to move the entire center mass more back towards the axle. I'd raise up the front plow if it's too low. You can't push it forward. I would maybe don't know, it still works now, like you can lift it up and push it forward to still make a trench. It's still faster than digging, so I accomplished the goal of my project. And
Are you going to continue developing it at all? Are you going to continue developing it?
I'm going to try and do the front plow thing, and then I might, if I can figure out the center of mass thing, I would develop it more, and then I would maybe even rent it out to neighbors to use or stuff like that. Use it myself as to start a business as a sprinkler repairman.
Other questions?
How deep does it
Oh.
trench?
The first hole here goes 6 inches, 10 inches, and 14 inches, I believe. I didn't remeasure it from changing the bar length, so I'm estimating based on how much we took off the bar.
And where are sprinkler lines?
They're not too deep. 6 inches is the most a sprinkler line should be. And then with sprinkler heads, they go down anywhere to like 10, 12 inches for a basic home sprinkler system.
Well, Tim, this is kind of opportunistic for me personally. I have a tree whose roots have sucked in the sprinkler lines. I'll get you my number.
Okay, any other questions? All right, excellent. Thank you, Tim.